I get distracted like more than 3 times.
After I went and saw the what are you doing? Just working at home. I was like, yeah, I'm being Caleb. Caleb is such a good guy. You tell him a story about how I love it.
But he's a bad worker. I leave early all the time. Sometimes I just leave.
All right, class is now in session. It's 8 o'clock. Let's see what you guys got as your solutions. And write them up on the board. We should have some chalk around. Who wants to go first?
This is section.
Preferably someone with good hand-eye coordination. Who wants to go first?
I don't like where this is going. I won't be able to catch it.
I'm gonna pick Colton. That was all my fault, man. That was a bad throw. That's why I didn't play quarterback. I was a linebacker. Here, let me give you another throw, man. There we go. That's better. Let me do another throw right here, man.
What?
I'll do one more throw. Here we go. Okay, so it wasn't just luck. There we go. Problem are you solving? All right, we're doing number 13. So you guys want some rulers for this one?
Yeah, that's what I got.
I concur.
Is there any others? Anybody do something? C is between A and B.
Just check again with your ruler.
Yeah. It looks really close, but it's like a
It's
hair
super
off.
close.
I hate it here.
You can use the rulers to 100% quantify the veracity of your claims. Is that shirt about a Gaussian distribution? Cam, is your shirt about a Gaussian distribution?
Yeah, it is.
There we go. Yeah.
This is the math club shirt from last year.
Oh, okay. Cool.
You go, Caleb. I'll just go down.
Problem 13. Child marking your book with flash trees. Which points are between each other? Yeah, I agree.
Oh.
When I applied my ruler, I got that. 3 points.
Oh, and 2.
You mind passing those out to everybody, I guess?
Yeah, we're gonna hope that this works out really well. Here we go.
Next week.
Whoa.
right on there.
This one is missing chalk.
Oh, okay.
Okay, so that one, and then we have another point right there. And that is the W, X, Y, and Z. So we have W, X, Y, Z. Absolutely massive brains over here. Let's see. Use your pencil mark all points that make a segment with O that is congruent to OP. So all these lengths are the exact same. Might not look too hot right now, but they are common. OP. We have U. I think it's W, X, Y, and Z, right?
Yes. And B.
Z. Oh, that's going to be chaotic, but that's okay. So if we were to like draw the outside edge, it would look like a circle.
Mm-hmm.
And the more that we would put on there, the more dense we could make this, it would just like create a circle over time.
Yes.
Yeah.
Yes.
I'm really hoping that somebody would notice me there. It's just not Thursday morning.
With 15, do you want me to put all 6 subsections up there at once?
Yeah, in order to keep it like, cycling through, we'll have you just do 3 of them and we'll have someone else do another 3. I like it when everybody kind of gets up and does something quickly and everybody goes through. Makes you all feel active and makes you all feel like you're participating. Problem 17 is the real one. That one's going to take a while.
Yeah, that one was.
That one I felt like was easy.
Okay, we'll see.
It was the reflections on 16, not 15.
Oh. Okay. On problem 17, I'm expecting you guys to prove it rigorously. Yeah. We'll see. One. What do you guys think? All right. What if someone for number 3 would have, instead of AC, written AD?
Would have been equal, correct?
Aha.
That's what I put, yeah, I was wondering about
It's
that.
the same thing. Yep.
They also could put the rate A, B.
So
Yeah.
wait, why is it the same?
Well,
Because B, C, and D are co-linear.
Okay, that's
so,
all I need, I'm convinced. You got me.
I mean, yeah, that's really all there is to it. All right. 4, 5, and 6. There's Alexis.
For 4, I'm not sure that it like matters. I think it's like the same, I put the same thing, but I just put like L for the whole line. Does that matter, or is that saying like the same thing? since it's all like,
It's the same line.
yeah, that's what I was wondering, I was like, is that, okay, for one?
So what does CD with 2 arrows on top mean?
The
A
one.
line?
It's the full line that goes through C and D.
Yeah.
So is that equivalent to L?
Yeah.
Why?
Because C and D are points that line out.
Yeah, they're collinear, as you said earlier.
Right.
Okay, so that's that. Number 5 being 5 you think is AC. Everybody agree with that? And 6 is BD. What do you guys think about that? Guys agree?
Concur.
All right, good. Time for Caleb.
Okay. Do I need to draw the triangle?
Let's see, what problem are we on? Yes. Yes.
Oh, here.
You're gonna need to describe a sequence of basic isometries that will make ABC coincide with YXZ. So yeah, you're gonna have to do it all. Show us all.
Okay.
It's a lot of room.
Yeah, it is.
Trust me, problem 17 is the one that's gonna take the whole class period.
Oh,
And if you thought it was the easiest one, does that imply you thought it was short?
Or maybe you just didn't.
Well, I
prove
kind
it.
of remembered things from high school geometry.
Uh-huh,
I had like a thought, I looked up the thought, and the thought was right,
okay,
so. We'll see.
we'll see.
I may be overconfident, but we'll see.
Okay, no, that's fine. For 17, 1 through 6, I'm looking for rigorous proofs.
Okay.
Okay.
So let's see if
That
we,
might take the whole class period.
right, yeah, I wanna, some really good arguments.
and the effort.
Never mind, I think this problem might take the whole class period.
I'm trying my best.
Okay, you ready, David?
Hashtag cool. I forgot what it was actually called.
Yeah, instead of a hashtag, you could just put 3 lines. I mean, now that you've done it, don't worry about it. I'm just saying in the future.
This weird thing.
Before was a hashtag with a font on, right?
That's it.
Yeah.
Well, there's actually another name for it too.
Sharp?
No. There's one that's like the official name for it. No one cares about it.
If we finish 17 early, can we talk about what's happening on Wall Street right now?
If it's like of mathematical nature,
It could be,
oh yeah.
we could twist it that way.
If it has something to do with geometry or math, then we could tie it into that. Yeah, we could talk about it.
Is it?
Mm.
I applaud you.
Thanks.
I physically cannot do it.
Oh, we have like a yardstick in there somewhere. On the meter stick.
Swear.
It used to be when you have to walk there.
dotted line. Make a million dotted line.
Yeah. Looks nothing close to an R.
Might need to use the ruler to make the R,
You're not wrong.
and then use the compass to make the curved part. Wow, you can do it when you apply yourself. Look at that.
Requires effort.
Brilliant mathematician.
And chalk broke. Is wet chalk.
So basically, you answered 16, both parts all at once, because it asked, can you do it? Could you pull it off utilizing only reflections? So yes. One way to do it is to do a 180-degree rotation clockwise and then reflect about a vertical mirror line. But then you could realize that, oh, you could just do it in one step, reflecting it the way you have it. So yes, good work. Now we're on to 17.1. Who's up? Bailey, you got good hand-eye coordination?
We have several bits of chalk.
Don't you play volleyball?
Yeah, but I don't catch them.
Oh, okay. So here we go.
Yeah.
Your goal is to not catch them.
Exactly.
Woo! There you go. It's not that bad.
Okay.
The cool kids catch it.
Now, this needs to be a rigorous proof.
Let's see it.
But if that's not what you have prepared, just show us what you have prepared.
Well, all I have prepared is that it guarantees.
Okay, let's see. Because only a rigorous proof would show that it guarantees.
Source?
Yeah, exactly.
I just said yes or no.
Yeah.
Yeah,
Please
that's
cite your
what I
answer.
Yeah, the question just.
So when you're writing it,
I kind of figured we were gonna go over
Put
this
your
in class a
sources.
little bit more intensely. So I was like,
I don't really know where
Yeah.
to start.
You don't know where to start? Okay, let's create two triangles
Okay.
and then draw them out. Draw two triangles out.
look,
One triangle called ABC, another triangle called XYZ. Wow,
Some nice triangles you got there.
that's inverted. Okay, so what does the SSS imply?
It implies that like each side, well, like this side, and this side are the same as this side, and this side. Then
Okay,
It's the same.
so you could write that out like using congruence with line segments,
Okay.
or you could just, between A and C, put one vertical hash,
Yeah.
between B and C, put two, and between, you know what I mean? Yeah. Yeah. Yeah.
can you do this with a backcountry?
You can directly show this. You can directly show that they are congruent. Yeah.
So would this be all you have to do?
Well, it depends, Are you presenting it to mathematicians or are you presenting it to kindergartners?
Whoa!
I vote to be a kindergartner.
And I know what it feels like.
Well, I'm training you guys to become mathematicians, so I'm gonna expect more. You can be a kindergartner at heart, which is what I am.
Yeah.
So I can't hate on that, but I'm a kindergartner at heart. But yeah. So what are the 6 conditions to prove that triangles are congruent? We have 6 conditions that have to be satisfied. What are those 6 conditions?
Is that in the book?
Yes, that's in the book. Let me see. Yeah. There's a part that explicitly says 6 conditions. So all the way down to the last sentence on page 11, this tells us that using CPCFC, that the 6 corresponding parts are congruent. So 3 legs and 3 angles. If the 3 legs and the 3 angles of 2 triangles are congruent, then they must be the same triangle, right? Geometrically speaking.
So what you have to do, sorry. Yeah, so we're assuming that the sides are the same,
Yes.
right? So then.
What's
that's
left?
Given, so we have to show that the angles are the same.
Yes. So we must show. Yes. Assume.
I'm just gonna say, what should I call it, hash marks?
You can say AC.
Oh, like.
AC is congruent.
X, Y.
Beautiful. Yep. Mm-hmm.
I love this so much.
Nice.
So much better than that.
Oh, my God.
It doesn't take much for that, though.
Yeah, we're not trying to learn a new language.
Yeah, we're not trying to learn a programming language right now.
So now I have to prove that the angles are all congruent,
Yes. And they have to be the angles that are like
corresponding.
Yeah. So between like the leg with 1 hash mark and 2 hash marks, in each of them, those have to be the same angle. So what does angle A have to correspond to in the other triangle?
One.
Yes. So write that out. We must show. So WMS, or fully write it out. When I write WMS, that means we must show. When I write WULOG, that means without loss of generality. These are all typical things mathematicians say.
My good idea is one.
WULOG.
Is that the official pronunciation of it?
Yeah.
Okay.
It's short for without loss of generality.
I want to write if.
If, yeah, if and only if. All right. Pick one of those angle congruencies and unpack that definition. What does it mean for angle A to be congruent to angle Y? What is an angle defined as in geometry?
The measure from one side to the other.
Yes, but how do we define it in the text? How do we define an angle in the text? This is a very unique definition to geometry. In trigonometry, the angle is some type of parameter that changes the values of x and y in the projection, where they correspond to the value of cosine and sine. But in geometry, an angle is defined as what?
So it says like, with angle A, there's this line, and then this is a line that's not on this line.
The definition of angle is on the bottom of page 10.
So angle A would be defined as the union of the ray AC with AB. So that is what angle A is defined as. That's what all angles are defined as. Remember that?
Yes.
It's on page
Bottom of page 10.
10. Okay. Wait, I don't see it on page 10.
So the very bottom.
Oh, very bottom.
Yeah.
Oh, yeah, you're right. There you go.
I have a question.
Yes.
If we can show like, I'm trying to think like if we can show that, then like to find the measurement of angle Y, and we use, could we say that like sine of Y is equal to, oh, no, that's for right triangles. Dang it.
Not only is that for right triangles,
Not right triangles.
we are assuming that we are like in the ancient Greek times,
Oh, okay.
prior to the invention of trigonometry.
Yeah.
Trigonometry was invented in Mesopotamia by Muslim scholars that took the knowledge of the Greeks that got preserved there, and then it got again taken in Europe after that. So during the Enlightenment. So before they didn't have trigonometry or algebra, they just had geometry. Yes, ma'am.
Oh, I was gonna try to see if we could like finish it, just because I had a thought. So can we say that that's what angle A is? And then say what angle Y is? And then since the two, things are congruent.
What would angle Y be? Tell me what angle Y is defined as.
The union of the rays, y-x and z.
YX union IZ. So we want to show these two are congruent. How can we do it?
Well, we already said, like, by our assumptions,
Yeah.
these are all congruent.
How are you going to use that? You're right. Those assumptions are key to showing these two are congruent.
Yeah, I was gonna say congruent parts, make the whole thing.
We can directly argue it. We can directly show it. So, for example, take AC congruent to XY. That implies the ray AC is congruent to the ray XY. Right?
Yeah.
That'll give you this one right here. Then take the segment AB congruent to ZY. Finish the next sentence.
I mean that the ray AC is congruent to the ray.
Yep. You see it? You see so the line segment is like a finite thing. The ray is an infinite thing. But if you know that the finite things are congruent, then their rays will be congruent. Because of what we said earlier. Remember I said for number 3, you had AC or whatever. Was it number 3? Go back in time now. Yeah. One of them was like number 3. Yeah, I have AD over there. It's AC, but they're the same, right?
Right. But if we use that to prove that the angle is congruent, that would mean that angle side to side works, which it doesn't, because
No.
right. Because if we use that to say that the angle is congruent, then we've got the so if we've got these two triangles, so okay. This angle goes this way. And then we so these sides are equal. We make a second side that's this long. And we know this ray. We know that this is the ray that's making that angle. So we've got
Told you this was going to take a long time. You didn't know you could phone a friend, huh? I'm not sure what's going on right now.
Yeah, more.
And you'll become evident.
It don't have to be perfect, like, we'll take your word for it.
Well, So. And this- Because it's saying that because this segment and this segment are the same, and this segment and this segment are the same, that this angle must be the same. Which is the reason that angle sine to sine doesn't work. Because you can form that two different ways.
Wait a minute. Are you saying that
Because like this segment here.
Okay,
Yeah, in order for them
Intersect
to work, in order for them, yeah, in order
twice.
for them to work, it has to be side angle side, like the angle has to be included.
yes, yes. So save that thought for when we get to number 4.
Right.
I'll let you do number 4. We're gonna preserve number 4 for you. So, Bailey, back to what you were doing. You were able to establish that angle A is congruent to angle Y, right?
But what I'm saying is, how does that establish that those angles are congruent? Because we've got the same thing here. We've got that, so if we've got the,
Don't forget that the fundamental assumption of this one is that all the sides are congruent.
right.
Whereas the
but, like,
fundamental assumption of what you're saying doesn't include all the
I
sides being
agree.
congruent.
I agree, but this statement right here doesn't use that third side.
We're gonna get to the third
Okay.
side. We're gonna show that all the angles are congruent. If we are given that all of the sides are congruent, we can show that all the angles will be congruent.
Okay.
Does that make sense?
Maybe when we get there.
Yeah. We'll give it a chance.
I'm not saying that will work out now.
That's okay.
Okay. Fine.
So right now, Bailey's trying to establish that the angle A is congruent to angle Y. Because then she has 2 more things to show once she does that.
Okay.
So
yeah.
she has 3 things to show so far. But if she can establish A is congruent, angle A is congruent to angle Y, then 1 is checked off.
Wait a minute, so if the argument for angle A, if we make that argument, aren't the arguments for every other angle the exact same?
Yes, the
Right.
hypothesis guarantees all the arguments follow from that, yeah.
Okay, so then if you just show angle A, couldn't you just say something along the lines of like without loss of generality, we can look at the other 3 cases the exact same way, or the other 2 cases the exact same way as we did for this one? Or?
Yeah, I wouldn't say without loss of generality. I would probably say it follows
Okay.
in a similar fashion that the rest are congruent. So if we can rigorously prove one of them, then yeah, it follows that the rest are congruent. Because all you have to do is state these obvious facts for the other ones.
Yeah.
It's given to you by the hypothesis.
Yeah.
So the fundamental key idea here is that if AC is congruent to XY, then ray AC is congruent to ray XY.
So basically just write that out and then you're done.
Yes, because if you show that AC is congruent, ray AC is congruent to ray YX, and you show that ray AB is congruent to ray YZ, then when you take their unions, you establish the congruence.
So you could be like, it is known that ray AC is the same as the line segment AC, or it includes?
It's not the same as, great question. So AC being congruent to XY implies that array AC is congruent to array XY.
Okay, gotcha.
So right now you have segment AC.
Mhm.
Show me array AC
So
and
red-
use a different color. Here you go. You ready?
Oh, no.
I'm gonna underhand this one.
Okay.
I'm gonna underhand this one. You ready? Okay.
Yeah.
Ah! Well, now we have 2 pieces or 3 pieces.
We got a lot of.
Aren't all rays congruent to each other though?
No. Here's array. Oh, well. If array has infinite length,
Yeah.
technically that's true. But, you know, like at this point, you could show, you could directly see that if AC is a segment, then yeah, the array, if you take a look, the array is congruent to the other array. So yes, if array has
When you say
the length of
congruent,
AC, the array is truly infinite. You're right. If we take the length,
when you say that they're congruent, are you meaning that they're pointing in the same direction or that?
yes. Remember, axiom says that congruence, if and only if the same length. Technically, array has infinite length.
Mhm.
So that's why you said aren't all arrays congruent.
Right.
So if you take any array, you can, through basic isometries, make it overlap to another array. Yes. But for the sake of argumentation, for the sake of saying having a rigorous proof, this is one way of doing it.
Right, so if I'm understanding what you're saying, then you're saying that because the segments are the same length, they must be pointing in the same direction?
Yes.
But that's directly contradicted by what's going on here. Because these segments are the same length, and they're pointing in different directions.
Yes, I understand that.
Like,
But that's
So
those are fundamentally different assumptions that what's going on in
right,
side.
but what I'm saying is I could use this same logic here to say that because this segment is congruent to this segment, and this segment is congruent to this segment. So if I label this, what have we got? So AC, so A, B, C, and we've got that AB is congruent to ZY. So Y, Z, and X.
Are you saying Z and B are congruent in angle?
I'm saying that we can use these same givens, right? That angle Y or angle A is the union of the ray AC and ray AB. And angle Y is the union of ray YX and ray YZ. Right? Because, and since AC is congruent to YX and AB is congruent to YZ, where am I missing something?
So
'Cause, like, obviously
what
this
you're
doesn't
showing is a possibility,
work. Mhm.
but we're not saying that the triangle on the left and the triangle on the right are the ones that are congruent. We're saying that the triangle on the left and a triangle that looks similar to the triangle on the left that doesn't have all the same angles shown to be the same is possibly congruent, given that all the sides have congruencies to each other. So maybe what you could do is write a formal proof of what you're talking about, really think it through and present it to the class. And we'll see what you're talking about then. Because right now, I don't see
I'm not
which
trying to
one.
prove that these are the same thing. I'm trying to understand why this isn't a counter argument to that.
Are you
Because like,
saying-
what's fundamentally different about this that's different from that? Because this is the same block of text here.
I have a smooth brain moment right now.
All right.
No part of me is sold that AC and XY are the same length.
I constructed AC and X, I constructed them both with this segment. This compass.
I mean, I'm saying like in the world of like, perfect geometric forms, I still, because clearly that angle there is different.
Right.
Angle A, angle Y.
Mhm.
I'm just not buying that line can be,
The line can be the same length and the angle be different.
That's what I'm getting at.
Yeah.
Yes, angle A and angle Y are not the same.
Right.
I think maybe, because I understand what Cam is saying, but I think maybe his argument might be more to show from that.
Yeah.
So what I'm
trying to
what
say.
I'm saying
Yeah,
is, when we
I don't understand how
assume
this
that
proves-
all three sides are the same length,
just look on the
you can't wiggle the angle anymore. The angle can't wiggle because that side is
I agree that
assumed to be constant and stuck in one amount. So you are fiddling with the
I'm not saying,
orientation of CA and Y, X, but you really can't, because that 3# length
Yeah.
is constant.
I'm not saying that side doesn't work. I agree that side works.
Oh,
I
okay.
don't understand how this is a proof of that,
It's just one way to,
because.
Argue
because
it.
of the-
it's one way to argue it. And in that case, that argument, we'd have to talk about that one. Which one is this for your angle? Is this for your side angle?
Yeah, this is side angle.
Okay, let's see. Do you have a rigorous proof for side angle?
Well, side angle doesn't work, and
Or-
this is the proof on the board.
Okay,
Like,
for why it doesn't work.
because this is angle side, and this is angle side, and they're clearly not congruent. Because you can form this triangle two different ways.
Okay. Well, that's wonderful.
Yeah.
But we weren't talking about that case at
Right.
this point in time, so.
Yeah, I think what he's saying though is that this question needs more, so that way you can't like contradict it with this.
Right.
So
I'm
maybe
trying-
the side proof just needs to be a little bit more regular.
I'm trying to say that
Okay.
this proof, as I understand it, is insufficient.
How do we make it sufficient?
I have a completely different proof in my head, but like,
Let's do it.
so. Brush it back here. Like, I don't understand this proof well enough to, so how I learned side by side versus different. Which is that, say we have these three sides. Can take this one. So this is a circle of radius of this side. And then so for number 2, now that lost my compass somehow. then. No, that's not it. What am I doing? Ah, it's from these ones. Get back to you on this. I'm gonna figure out what I'm doing.
Okay.
So wait, can we talk about why we maybe don't think that 17 is like sufficient? Like, I mean, I'm going at this with like, I'm an open mind, whatever, but like, can we talk about why it might not be sufficient?
Because I don't, what I was saying is that I don't,
Like, what assumption are you saying is not true?
this one. That because these are congruent parts, that they're congruent angles.
Okay,
Well, we were saying that for like, not just for the angle AY, but we were gonna say that for all of them.
Right. So is it that you need all three for it to?
maybe?
I
I,
mean,
I think that would be a little more convincing.
Yeah, all three. You can use this argument to achieve all three.
Well, I think what he's saying is, do you need all three of them to be true?
Yes.
For any of
Or
them,
that to be
for
true.
any of them to be true.
So like if one of them is true, it's not sufficient to say that side is, like, I mean, don't get me wrong, I agree that side is enough to say they're congruent.
Mhm.
But it's basically we need, if you have one of them, you have to have all three of them are true in order for that to hold, right?
I mean, if you think about it, if all the legs are congruent,
Mm-hmm.
then the angles should be congruent.
Right.
But them should be congruent is not rigorous enough. So we have to show it. So how do we show it to
So-
satisfy the definition of an angle based off of the geometrical version of definition of angle?
Yeah, I think you have to do that with all of them.
Yeah, you have to do that with all of them, and your hypotheses allow you to do it for all of them.
Like if-
Oh, because
if
it
one of
hinges on
them-
a hypothesis.
Yes,
one
your
of them-
three hypotheses will give you your three angles.
Now, the difference here is because, the difference in this case right here is because we're not assuming that all the sides are the same.
Mhm.
So clearly, because all the sides are not the same, then,
We're showing
changing.
that they are. We're
Yeah.
showing.
well, I'm talking about the case that Cam was putting up there.
Right.
So with that
Right.
one, because the sides are not the same, clearly the angles are not the same.
They're not necessarily the same. No, as he showed, you can get that same 2 hash and move it through a different angle.
Yeah, I'm a little bit more convinced now about like,
But we're not talking about that case
Yeah,
right now.
yeah.
And although that's a really cool example that Cam showed us, and although we appreciate it, we first have to flesh side out.
Yeah, I think.
The reason he brought it up was because he thinks that the way we're proving it isn't sufficient.
I think,
So that's
Well, I
that's
think-
what is,
Yeah, I
you know.
think you have to prove it with all three angles, and if all three of them work, then you can say.
But they do.
They do for side, but if you try that same argument with this one, you would reach a contradiction.
Yes.
So I think he was just wanting all of them on the board to say
Uh-huh.
that one works.
Uh-huh.
I
Okay.
think that's what it was
I
trying
don't
to
wanna
say.
take three.
Is that true, Cam?
If I understand everything everyone's saying correctly, I think so.
Oh, okay. Well, you guys, the consensus is up to you.
Yeah, if one of them doesn't work, then they're not congruent, and therefore it's not side, right?
so
What do you mean by one of them doesn't work?
Like if one of the three doesn't work,
Uh-huh.
Then that means that
then
the
it's
segments
a
are not the same,
contradiction.
and that contradicts our
It
assumption.
contradicts, what you assumed, so it can't be side.
Lots of wrinkles.
Yes.
Wrinkles.
Yes. Very good.
Yeah, that's
Very
what we're
good.
trying to say.
Oh, yeah, okay.
I'm with you now.
That's
I'm
really
with
good.
Cam, are you with
Yeah,
it
yeah,
now?
I'm with it now.
Okay. So, all right.
Hey, but that's good, that's.
What I want to know is, notice that you can apply this argument to the A and the Y, angle A, angle Y, angle X, angle, its corresponding one, and yeah, C, or yes, C, and then the angle B to Z. And you show all the angles are congruent then. Is that sufficient?
Yeah. Yeah, I think so.
Because remember, there's 6 aspects of a triangle we have to verify. The side lengths have to be the same length, so that applies same length, congruent. And then we have to show that the angles are all the same. So based off of the given side, does this argument to each of the angle correspondences satisfy you guys?
Yes. With
It
all
does.
3 of them, it does, yes.
Okay,
So if one, okay, yeah, I think we're good.
I think we're good.
all right.
Yes.
That's what I was trying to say when I whipped out the 3 hash marks, was I was trying to say, yes, what you're saying may be correct. You can modulate that 2 hashed leg like so. But if it's under the assumptions we have, you
Yeah.
really can't modulate it because that 3 hash leg has to stay at a consistent value. And triangle left and triangle right, we wouldn't be able to have 3 hashes on them because they're clearly not congruent. Okay,
So
good.
You're with it though, right?
Yeah.
Okay.
Good,
All right.
good. So,
Oh, yeah.
Pro- so there's nothing wrong with being passionate. Cam's passion came out and he was like, whoa, I have an idea. I want to bring it on the board.
All right, so you need this for.
I mean, that's gonna.
You can work over there on that side.
Okay, like if you erase it, I'm just gonna have to redraw it later. That's no fun. We don't want to do that.
Ultimate jerk move.
I should have just done it. Angle.
Yep, triple A.
Wrong, very wrong.
Not enough.
Now we got, show us.
No. Okay, here we go. So, let's say we have this triangle right here. Right?
Follow me so far?
I can't read it. Make it
All
bigger.
3 angles are the, like, so,
3 different angles is what that's saying.
Oh, 3 different angles, okay. You'll see that me saying, oh, draw it again.
Yeah.
no, those are.
That's
so
some
these are my two
foreshadowing.
comparisons here. These are my 2 comparisons.
Okay,
So the angles are the same.
uh-huh,
The side.
Okay, so what this does is it makes similar triangles.
Aha.
Congruent triangles.
aha. That's what I meant by foreshadowing. Yeah, nice dance moves.
Woo.
Foreshadowing by, oh, what you guys just said.
I think that's the full proof though.
That is the proof.
No.
Yeah.
That's all you need.
All you need, okay, so we have a hypothesis or a conjecture.
No.
The way to disprove a conjecture is to show one counterexample.
Counterexample.
Right there.
Boom.
You showed two sets of triangles who have congruent angles, but they don't have congruent sides. They are similar triangles. But yeah. So notice that here, that's all you need.
I would say drop the mic, but then you'd probably break this up.
Yeah, that's right. Yeah, this is.
Boom. Put some there you go.
Don't forget
Exclamation
your
marks, yeah. Boom.
Lots of wrinkles.
There you go. Wonderful,
really bad Irish cereal.
wonderful. Lots of wrinkles. After me pot of gold and some lots of wrinkles.
You got it.
All right, 2 is out. Time for 3. Who's got it?
Colton.
Colton.
I hate it here.
Oh, you need me to throw some chalk at you? You got one? Oh, okay. I'm gonna throw some chalk at you. Yeah. Woo! That was a bad throw.
Dean Colton played rock, paper, scissors for that one and he lost.
I'm just gonna do my thoughts on side.
Okay,
That's the thing I was trying to do.
all right, okay.
Feel free to erase mine, I don't care about it.
You did it on, I didn't mean to.
Can do that one, the grinder.
Yeah, I was like, "Good deal."
And side, base.
Okay, wait, I actually don't like it.
On the second one, the angle.
Yeah.
Oh, you're right. Yeah, that's. Okay,
Not good enough proof for me.
I'm convinced.
Yeah, I'm convinced. Sick. It works. Did we just like evaporate out of here?
yeah, sure did.
Alright, cool.
I don't hear you guys. You were here all seven pages. What do you think? I really did. No, you didn't. No, you didn't. You said you were doing that one.
What do you think is happening? Really, 'cause the whole time I was reading this, I was like, Caleb's gonna have a problem with this.
No, I actually was.
Are you insulting his literacy skills?
I didn't know it.
No, I'm not doing
You
that.
actually read it all? Really?
You're surprised both of us, Caleb. I figured you'd be like, this is dumb education, so I don't want to read it.
No, I was like, hi.
Really?
Yeah, look at you. This is your year.
Who is this Caleb?
So,
Always keep them guessing. Whole meal, we broke out a third triangle. Ish. You're 2/3 of a triangle.
I was gonna say that. I don't know. Ever since you moved out, you've changed. Yeah.
You moved out? Or what, like your parents' house?
There's a lot about her. It's all the time.
Yeah, she can move, but now I move them.
It's too late.
I want to like come back and move out to here, I mean, so, for sure.
Okay. So. I'm starting with the classic, assume that side AB is congruent to side XY, and then just lay all that out.
Oh, no, I'm so pretty.
Yeah, I think that's a good place to start. When you don't know what to do,
Assume,
write down your assumptions.
You don't know what you're doing, just start assuming stuff. Circle again, that's what we call it.
And then I also
So what is it that you have to show?
show that these angles in this length is equal as well.
Yes.
So
Side, angle, side.
I have a question.
Yes, ma'am.
Okay, so this is side angle side, right?
Uh-huh.
We already proved that side works.
Uh-huh.
So if we can just prove that side BC is congruent to XZ, can we just say, since we already proved that side works, all the angles fall into place?
Yes. Isn't that cool? Yeah. Now, the way I show it through exhaustion. I just directly show everything. But that is a very lickety-split way to show it, and it's just as valid.
So you could just write. Okay. I want to prove they're saying suppose that these lengths aren't the same, and then that can't happen. Can't happen because it'd be a different time. I think.
Okay.
Okay, well, I-
So write it out. Write out exactly what you're saying. Now suppose BC not congruent.
Is there a thing for not congruent, so like not equal?
It's just like congruent with a slash through it.
So it's basically just like they're not equal?
Yeah, that's how I do it.
Nice.
Okay.
However, this what?
Contradicts our assumption that, like what we assumed. Because it'd be a different triangle. Those lengths aren't the same.
Do I just say that? No.
Cam, I know you want to jump in on that one.
Sorry, I was floating in my head.
Well,
Contradict our assumption. So assuming AB is congruent to YX, and angle A is congruent to angle Y,
Yeah.
and CA is congruent to ZY.
so side, angle, side.
Yeah. Now suppose BC is not congruent to XD, contradicts our assumption.
Where it'd be a different triangle. Just write another triangle. That would good. This would be this BC. This be X1.
If side BC isn't the same length as XZ, A would have a different angle. And if you extend the line, you
Yeah,
extend
that's
the
what I'm
other
saying.
line, it'd be a different angle. Is that what you're trying to say?
Yeah. Like if these aren't the same length, then this angle is different.
What if we looked at them both as just rays without, is that like a valid way to look at it? If we like remove that whole side, that BC side, we look at them both as rays. And then from there, you try and show that the length BC is the exact same as the length x. Maybe? But that's kind of like what you're trying to show here, but without like saying they're triangles. Kind of. I don't know. Maybe it's a smooth brain on it, but
So-
yeah.
So, okay, hold up. So BC not congruent to XZ, that implies the length of BC does not equal the length of, what is it?
Ooh, yeah.
What is it? XZ, right?
So then from there,
So if two real numbers are arbitrary and they're on, because their lengths are real numbers, right? What can we say about AB? For two arbitrary real numbers, there's three possible cases. Case number one, A is equal to B, right? Well, that's not our case because we're assuming that they're not equal. So that's case number one. Case number two, A is less than B, right? And case number three, yeah. So these are your three options given any two arbitrary real numbers, where we can say A is this and B is this. So we're saying that they're not equal, so case one is out of the picture. So it's either this or it's either that.
and then if you show that, wait.
So if they're not the same and you have, so XYZ is a bona fide triangle. So I don't know why it doesn't have a line segment connecting X and Z.
Because I was thinking of it as a ray. What Caleb was talking about.
Yeah,
I see, okay.
I see what you're doing here because we're kind of like taking those cases and putting them in like the example right there. So we're saying that case one, BC is the same as XZ, but we're assuming that's not true.
Right.
So then we need to show that the others aren't true.
And without loss of generality, you
Yeah,
could just
yeah.
pick either of these, right?
Yeah,
Pick one of them, and if you show it for one, it will imply the other.
yeah.
Okay. Or if you show it's contradictory here, it's contradictory there.
So contradiction for both cases then, or just one?
So you could just say, okay, if they're not the same, assume, let's say BC is shorter than XZ, for example, or longer. It's either shorter or longer if they're not the exact same length, right?
Mhm.
So pick one, whichever one you want. The proof wouldn't change whether you picked either or. Does that make sense?
Yeah.
Okay, good. If it doesn't, say so.
We're saying XP is longer than BC,
Okay,
and
now what?
it contradicts our assumption that the angle A and angle Y are congruent. Is that they're not? Okay, right?
Yeah, I feel like that, I mean, like, it's like we need to show why, right? Like why those angles aren't the same. I
Could
guess
you
say-
could you on the bigger triangle put all the congruencies that are there? Of course, the BC XZ congruence isn't there, but what are the congruences that are there? The AB to,
For this one,
yes.
if it was longer, I guess I could only do one. Because everything else would change. That makes sense. Okay. X and Z are super long.
Are you saying, can I hold, Colton? So you're saying like, so this is a side, right? This is another side, this is their angle, and if you change this length right here, the angle changes, right?
No, we need to, I guess the only thing you need to show is like why that's true. Because the angle X is the union of rays XY and XZ, right?
Mm-hmm.
So, give me a minute, we're buffering.
Here's the progress bar.
Yeah. I guess you need to show why that angle is not the same. Like, wouldn't that be the only thing you'd need to do, maybe? And that would be a contradiction from our assumption. And then they must be equal, or, yeah, maybe.
I was wondering if there's a way to do this that doesn't involve contradiction, because to me it seems really hard to prove that.
Yeah.
What you're saying is correct,
Yeah, what you're
Colton.
saying is correct.
So you're saying, okay, if XZ is bigger than BC, that will change that angle Y, right?
Yeah.
And we were assuming that angle Y was congruent to angle what? A. So if you change angle Y, you'd have to change angle A, but that's a contradiction. Right? It is, because if you extend that leg out longer, that angle, as Alexis was pointing out, will change. So that contradicts your fundamental hypothesis that those two angles were congruent. So it's impossible for XZ to be longer than BC. So that's not possible. What about this case now? So case 2 is impossible. What about case 3? Which hypothesis will that mess up?
This one?
The same one, right? It messes up the same hypothesis. So that's it. This case doesn't work as well. So assuming that they were not equal led to contradictions. So that means this must be true, that they are equal.
Which means that it does work. So the answer is yes.
Why does it mean you're done?
And then I can point to problem 1 as like shown side, side, side.
Yes. Does that make sense? Yeah, it deserves a clap. Yep. Yep. Deserves a clap. So this is how you do proofs. You say, okay, assume we're trying to set up contradiction. So we want to show BC is congruent to XZ. Let's assume it's not and see if something logically messes up. What messed up is that hypothesis that Y is congruent to A. Whether it was shorter or longer, it messed it up. So they must be equal by contradiction. And your proof is complete. Because SSS. That's rigorous.
Yeah.
Very good. Well, it looks like we only got to 3, and there's another 3 left.
Oh, we got 4.
Oh, we got to 4? Oh, yeah. Is that sides? Which one?
That's angle side side.
Angle side side. Oh, angle side side.
Or side angle.
Oh, did I accidentally reflect angle side side to be ass?
Yeah.
Oh, okay.
There's a reason they write it in a certain way in textbooks.
Yeah, because my immature self would be like, ha ha, ass.
Exactly.
That's how my intro geometry teacher taught us.
Oh.
That it didn't work. Taught us to remember that one didn't work.
Yeah,
Exactly.
it's the ass case. Yep.
Yeah.
No.
Yeah.